Hi, today we will discuss about nuclear size of the nucleus. As you know, nucleus is at the core of the atom. So, nucleus contains nucleons. Nucleons are protons or neutrons. The particles inside the nucleus are called nucleons. So, the number of protons and neutrons inside a nucleus is given by atomic mass number, that is represented by letter A. As the number of nucleons increases, naturally the size of the nucleus also increases. The density of the nucleons is considered as a constant. Then radius of the nucleons, if we take, is represented by R. The size of the nucleus depends upon the number of nucleons. As the number of nucleons inside the nucleus increases, the size of the nucleus also increases. So those two are related in some way. We will look into it how the radius of the nucleus and atomic mass number A are related. Now, we have to remember that nuclear sizes are of the order of 10 power minus 14 to minus 15 meters, that is around Fermi, whereas atomic sizes are 10 power minus 10 meters, around angstrom units. Bigger the atom, more number of nucleons it contains, hence the bigger the size of the nucleus. So we will look into all these things now. Let's see how the radius of the nucleus and size of the nucleus and atomic mass number are related. Let's see. So let's look into the nucleus. Suppose this is an atom, and atom contains nucleus. So this nucleus contains again nucleons. So if you take this nucleus contains some protons, neutrons. So generally the number of nucleons are represented by the letter A. A is the atomic mass number. Atomic mass number. So the size of the nucleus depends upon the number of nucleons. Suppose I have 3 nucleons. So the size is like this. Suppose I have 10 nucleons. 4, 5, 6, 7, 8, 9, 10. So obviously the size of this one and the size of this one is comparable. So this is a small, this is a large. So as the number of nucleons increases, this has, suppose this one is N2, so N2, the number of nucleons are more. The number of nucleons are more here. Now suppose, let's look it into the relation. So here, suppose here if you take in this one the radius of the nucleus. So if we have more number of nucleons inside the nucleus, these are all tightly packed. Even though I am showing as a little bit more not tightly packed. Suppose in this one the radius so the radius R depends upon the number of nucleons, that is the number of nucleons, that is atomic number. So actually they are not related directly, they are related by some relation, that is a power 1 by 3. So as you have seen, that is r equal to a power 1 by 3. Not only a power 1 by 3, actually if we take out the constant, so proportionality if we remove it is a r is equal to r naught into a power 1 by 3. It is atomic mass number related. Now the value of r naught is nearly equal to 1.2 fm. Fm means Fermi, that is equal to 10 to the power of minus 15 meters. So this is the relation between the radius of the nucleus and atomic mass number. Now suppose if we want to calculate the mass of an atom, suppose if we have the carbon atom, we want to find out the size of the nucleus of carbon atom. Let's take one example. Let's see some example. Let's take example. Okay. Now the carbon atom contains 6 electrons and 6 protons and 12 C6. So it is something like similar to X, A, Z. So the number of nucleons is given by number of nucleons is given by A minus Z. So A minus Z gives the number of nucleons. Actually these nucleons are neutrons. If you want to find out the neutrons, you can use this formula. So, but if you want the number of nucleons, nucleons means protons plus neutrons. So if we want to find out those things, now we will take eraser. So the number of nucleons, protons and neutrons is given by atomic number A, atomic mass number A. So this mass number gives the number of this is so in this formula A equal to for carbon it is 12. So let's find out the radius of the nucleus of the carbon. This is a formula we know, r equal to r naught into a power 1 by 3. So r naught we know 1.2 Fermi. So 1.2 Fermi, let's don't make into power of the tens into, let's take 12 power 1 by 3. So this is nearly equal to, if you do the problem, it will be nearly equal to 2.7 Fermi. If you take similarly, you can find out the nucleus of uranium. Suppose for uranium will have so many isotopes. Let's take uranium contains 92 is the atomic number and atomic mass number is 238. 238 is non-fissile. So it will be its nucleus radius. For uranium, the radius, if we find out, it will be around 7.4 Fermi. So like that way, now we have discussed about the nuclear size, how the nuclear size will depend on the size of the nucleus, that is number of nucleons in the nucleus, that is given by the A. It is a cube root of A, atomic mass number. The size of the nucleus depends upon the cube root of the atomic mass number. That is most important. Here we have taken the density of the nucleons as constant. So in the next lesson we will learn about further properties of the nucleus. Now, thank you.